Well, hi, and welcome to part 11 of the SC30 Reloaded assembly slash troubleshooting streaming series. Um, well, we still have a non-functioning SC30 computer here. It is not executing any ROM code whatsoever. The CPU just immediately gives up. So there is something that's wrong on the board. It could be a dead component, it could be bad solder joints somewhere. Well, one of those two probably. Um, as a baseline, let's start out by turning on the SC camera, but this is just garbage. This is whatever it's in the video, what was in the video RAM when it got initialized. So the CPU isn't doing anything. It's supposed to clear the video RAM so that we get. Switch over to close up here. Let's unplug the logic board. Replacement, so brand new ICs. So here's bag of goodies, baggies of goodies. Let's put them over here. So what we have is this IC is brand new. I replaced this. I believe these two are all of these here, except for these resistor packs up here, which I've tested. They test fine. Resistor pack here tests fine too. This one I'm not so sure. I couldn't source a replacement for that, unfortunately. But the lead right now is that the circuitry around UH7 is probably try and look at what kind of signals we're getting on these logic chips. The Handtech handheld oscilloscope, Handtech 2C42. This is rated for 40 megahertz, so it should be, it's not ideal probably to use with this machine. Some readings. This circuitry itself is running at 16 megahertz. So at least this teeny tiny screen here. I've ordered a USB-based, more easy to read stuff up on the screen that I can just show. But for now, this is what we have. So yeah, we have the probe here, and there's my ground lead for the probe. I've extended it with this little alligator clip here, just because it's very short by design. Get accurate readings, then you want to connect the probe's ground to somewhere as close as possible, ground as close as possible to where you're measuring. But we don't really, we just want to see that, just extend this. It adds a little bit of interference. But yeah, so I added this little clip, it's a very crappy clip, by the way, because this little hook here bends so easily, doesn't hold on very well, but it works for now. I'm gonna do a better solution at some point. So yeah, we'd actually need the SC30. Let's flip it around. Interconnection cords. Let's hook it up like so. And as a matter of fact, we should. I guess we should start down here. This is the LS393 on UG8. So actually, let's look up UG8. It's on the video mux circuitry. Okay, no lookup there. But I think if we search for this component on DigiKey, we should be able to get a data sheet like so. So we can see roughly what the pins are supposed to do. So here we go. So this is the the pinouts. So I honestly I'm not an expert on logic. But let's see here. If I understand correctly, so the logic has input and output, right? So it'll take several different signals and then create an output depending on the internal logic. So 1 and 30 says here, input A, 1 and 13. Clear input 2 and 12. So 1, 2, 12, and 13 are the inputs. And 3, 11, 4, 10, 5, 9, 6, and 8 are the outputs. So that should give us an idea, right? Let's start with 1 and 13. 1 CKA, 2 QA. Right. So we have 1 QA, 2 QA. So how does that work? 1A, 2 QA. So we should first check what package we have here. Is it LS393? It's 14 pins. Oh, 6. Is it 14? Yes, 14 pins. So it's this third one here, pin version. So what I think is going in, so 1A is the input for 1 QA, 1 QB, 1 QC, 1 QD, I believe. And then pin 2 is the clear for that range. And then 2A is the input for 2 QA, 2 QB, 2 QC, 2 QD. And then we have 2 clear, and then ground and VCC. Okay, that's pretty straightforward. So we should start out by checking the voltage, perhaps. We can see if we get clean 5 volts for this chip. So let's start out by doing that. Let's bring out the multimeter. You can just put it on the side there, just for as a sanity check. Let's see what kind of voltage we get. So what we wanted to measure is pin 1. What was it? Let's check again. 14 is VCC, 7 is ground. So it should be these two. Okay, let's turn this on. Should these two? Oh yeah, there we go. 5.02 volts. That's a pretty decent voltage right there. So power supply is doing its job, at least. Now let's turn on the oscilloscope and see. Let's check again. Pin 1 is input for 1. So it's right here. So let's do auto. So that's something, right? The input seems like a signal, all right? Logic. And then 2 is clear. Output. There we go. Output. Output. 13 is the input for 2. Looks similar. And then clear. Yep. All right. So, you know, the input and output has, you know, a waveform basically. It's not constantly high. It's not constantly low. Actually, let's have a look again. Yeah, so the waveform seems to go between 0 and 4 volts. So it's not quite 5 volt high, but it's a thing. So anyway, let's look at the second chip. So input looks the same. Actually, it looks slightly different. So this is the waveform for this chip. This is the waveform for the other. It's still maxed out at 3.6, 3.5. Seems kind of low for the input. Output. So pin 6, oh no, there it is. That looks okay. All right, how about the other side? So there's the 5 volts. Then we have this is the input for the second channel. Okay, it doesn't read very well. Let's try to auto set. That looks better. So those waveforms look all right. All right, so the LS393 seem to have what looks like reasonable waveforms on the input and output. So those chips may very well be good. So the next thing we should look at is F253, which is UD8. UD8. F253. F253D. Open up the datasheet, see if we can make sense of what this is supposed to do. So yeah, let's see. So this is a 16-pin package. So we should be looking at the first schematic here. See 0 through 3, which I assume are the outputs for that. I guess the B is the clear again. See if we have explanations for these. Again, I'm learning here. Inputs, select A and B. Okay, so the selects and then the data. Okay, so we should be seeing C through 0 through 3, we should be seeing data lines, and then strobe output. So A and B are the selects, G is the strobe, Y is the output, and then we have VCC and ground. Okay. Y. Okay, so select and data. So let's see what the select signals look like. A and B. So B is pin 2. Let's see here. Pin 2 gives us. Interesting. Oh, sorry. I need to go here. So that's a waveform. Okay, it's about 4 volts. That's B. That's then G is the strobe. Let's see what strobe looks like. Nothing happening. Those are the data inputs. So let's see what they say. Nothing really. It's just all over the place. That's just all over the place. Okay, so to be doing anything. Let's have a look at the screen. Yeah, we still have the same garbage on the screen. And then 1Y is the out. And ground, we don't really test ground probably. BCC. That's nothing either. That's weird. This chip is not getting any voltage. 16. Let's test with the multimeter just to see if we're getting something different. Ground is 8, VCC is 16. And that's 5 volts. Okay, so UD8 does get 5 volts. Why aren't we seeing this in the scope then? Getting anything. Wait a minute. Power cycle the computer. we're not really getting any signal at all right now. I don't know what's going on. Chips are so hot. So I'm not sure why my scope isn't giving me any kind of signal. Must be something obvious. There, okay. So it's just, so here we got that waveform again. Let's test these again. Okay. Yeah, some of these are just high. Anyway, let's have a look at the pinout again for this chip. Pin 2 and 14 are the input selects. 2, that's one select. 14, that's the other select. They look about the same. And then the data are 3, 4, 5, 6, 7. It's auto set again, so we can see the waveform. Okay, that doesn't look like anything. Yeah, my scope can't make sense of the data lines for. Okay, so that one is just nothing. That is 1C1. So pin number 5 has decent data line signal, but the others don't. And on the other side, 13, 12, 11, 10. So yeah, F253, again, I don't know exactly. Also, we have 3 more of these actually, so we can definitely do some comparisons. But yeah, they do, so they do seem a little bit weird. So that's select. These are data, 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 data. And output. Okay, so the output is a waveform. And then we have the 5 volts. In 2G is the 2G. 1G, 2G. It's a strobe. Nothing really. 1G. Data. Side, so there's the VC strobe. select, data, 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 data. No, that's data as well, and then output. Strobe, select, data, 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 output, ground. Over here we have the 5 volts VCC, have the strobe, have the select, data, 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 data. So they see, but some of those data lines look weird, and that area was kind of cap juice damaged, so it could be a thing. And let's have a look actually at TL UA9. It's this one. Let's power cycle the computer. So let's see what this is. It's a low noise FET input operational amplifier. Okay. Yep. So pin 7 is VCC plus, 4 is VCC minus, IN minus, inverting output, IN plus, non-inverting output, NC, NC, NC not connect, out is output. So we have 2 inputs, 1 output, 2 power supplies. So let's test the voltages first. See if the chip gets the right voltages. So that's pin 4 and 7. Pin 4 and 7. Where's ground? Oh, VCC minus ground? I suppose so. So 7 is plus, 4 is minus. 7 is plus, 4 is minus. Let's put it over here. 24.3 volts. Okay, what if we test against? Okay, yeah, okay, got it. So it's not. So we test against 12 there, 11 minus 11.58, and then we have 12.72, which is fairly high. The 12 volt rail problem. What does the so here is the redrawn SC30 schematic. We can measure through the top there. Let's just check what the 12 volts and minus 12 volts gives us. So I'm pretty sure, and then can measure against the edge. 12.72. Okay, that's pretty high. 12.72. Minus 11.58. Yeah, that 12 volt rail is high. 12.72. 12.72 volts. Let's make a note of that. 12.72. I don't know if that's enough for the machine, the logic to just not work, but it's definitely something to look closer at. Let's see here. So let's see what the other ones, the inputs. So pin 2 and 3 are negative and inverting and non-inverting and inverting input. Got the ground again. Oops. Scope has turned itself off to save battery. Thank you very much. Okay. Not really getting any reading. Pin number 6, 1, 2, 3, 4, 5, 6. No activity really. No activity. Okay. Not really sure what that part is doing. So it's hard to say whether that is okay or not. Could have to do with the audio right there. So maybe if there's audio playing, we'd get activity there if it's an amplifier for the or the low noise amplifier. But since the CPU isn't doing anything, we can't really get audio right now. But it sits next to the two Sony and audio chips, so that probably makes sense, I guess. I think we should test the LS30 chip as well. So I see. Where's LS? Yeah. So I have a replacement for the LS30. That's UJ6. So let's see what UJ6 does. IC gate, NAND, 1 channel, 8 inputs, 14 SOIC. This is the LS30. Let's look at the data sheet. So what we have is the, again, 14-pin SOIC. Both of these are 14-pin. It's the top one that is the LS30. So that's the one we should be looking at, I'm pretty sure. So we have VCC, ground, not connected, not connected, not connected, A, B, C, D, E, F, G, H, and Y. So yeah, the logic diagram says we have A through H inputs and Y is the output. So we can start looking at the inputs. So pins 1 through 6, or I guess first we can just make sure that the chip has positive current going into it. So we want to take a quick look at pin 7 for the ground and 14 for VCC. So ground sits over here. VCC, yep, 5.02 volts. The CPU is fairly warm now. So it's still not doing anything. So nothing. It's really happening. Nothing. Nothing. On ground, of course. Ground. So well, nothing meaning that we have 101 millivolts. So no inputs really. And then we should check 12, nothing, 11, nothing. And then of course the output. The output is kind of just floating there, not really doing anything. Yeah, so the LS30 is not seeing any, that's a thing. But I mean, it's not getting input. So it makes sense it doesn't really give any output. So that's a fairly inconclusive reading. Whereas the F2, let's have a look again. Yeah, the outputs are 1Y is identical, which seems to suggest that those chips are not necessarily bad. There must be something with the input. So yeah, the LS393, there's nothing obviously wrong with these. F253. LS393. These again are the 14-pin chips. So we looked at these. Let's look at the outputs again here. Three, four, five, six. Three, 4, 5, 6. These waveforms, it says max 500 millivolts, which that's not really, that's way too low. Yeah. But 8. Yeah, if it's any of these chips that look iffy, it's these LS393s. Because the output is pretty, the peaks are at 500 millivolts. So what are the inputs again? So 1A and 2A, pin 1 and 13. Pin 1, 13. Yeah, so I mean the inputs are also just 500. So it might not be these chips' fault at all. They get hot though. They're pretty hot. LS393s. So if produce 500 millivolts, right? So yeah. But if I was gonna do the shotgun approach of just swapping something out, it would be probably these two chips, because that's the part that's not producing good outputs, but the inputs are not good either. So we probably also want to look where the inputs to the LS393s come from, because that could be the problem. Seems more likely even. But thank you for watching, and we'll pick this up again another night and see what we can figure out. Bye.